I had some hesitation to show this circuit. It's one of the circuits that I've published many times on my YouTube channel, an Astable Multivibrator. Paid a lot of attention to it, etc., etc. But the idea of this experiment was to find out how with such a simple multivibrator I could get to the highest frequencies. Well, that was in a certain way a sea to drink anyway, and this is only an experiment. And here is the schematic. Because I wanted to get to high frequencies, I used the BF199 silicon NPN silicon high frequency transistor. Schematic is here. And at first I have connected two capacitors of 180 picofarad trying to get to the highest frequency. Anyway, we will look on the scope what that all meant. And of course, when you have a multivibrator circuit and change such a, in a certain way, tiny capacitor of 180 picofarad and parallel it with 0.22 microfarad capacitor, and also here you will surely see that the difference between these two capacitor values is extreme when we are talking about capacitance. That also means that say the waveforms change in a certain way, in an extreme way. My first idea was to give each transistor a separate tuning resistor, but finally I went to this circuit, only one resistor, that's what I mean, only one resistor here that sets the base voltage for the first and the second transistor, and to protect it with a 10K fixed value resistor. Anyway, so let's look what this circuit can bring. It's a very sloppy circuit with very sloppy waveforms, but perhaps it's interesting to show, say, the different waveforms that this circuit can make, and they are of course useful in practice, absolutely sure, etc. Well, this is the sound at the moment. Very low frequency is now generated. I will switch off the lights. And we are now on 665 Hertz with this circuit. But when I do minor changes, say tuning the potentiometers that you've seen in the schematic, there are, say, dramatic effects. So that's why it also is sloppy. Here the beep that we hear. I changed now one of the potentiometer from the second transistor to the base. Let's see. That surely works. But when I changed the, say, the voltage to the base of both the transistors, it also will change, surely. So here you see and hear that. So that means that you can need this sound. Anyway, it's possible with this schematic. Let's listen again. Always interesting anyway. Well, this is a kind of normal sound of a Astable Multivibrator on lower frequencies. Well, let's try to get to higher frequencies. And I have to switch on the light again, showing the schematic again. What I want to do now is change this potentiometer, switch to the 280 picofarad capacitor, so remove that 0.22 microfarad capacitor that bridges that 180 picofarad capacitor, and let's see what happens. Because of the use of the high frequency transistors, I think that can work. Of course, for my earlier experiment that I've showed, I've switched in the two 0.22 microfarad capacitors. So let's see what happens. We are now, by the way, on 23 volts. So 23 volts. Let's see whether we can get an oscillation here. Well, turning here this knob that sets the base voltage, you can surely see here all these frequencies that are generated. And what is that frequency? Well, let's look on the scope. Well, this is the frequency. It is 664 kilocycles. With these 280 picofarad capacitors. This is a waveform here, there's ringing, etc, etc. Anyway, let's try to change one of the potentiometers. And now we are on 1.7 megahertz. Well, that's not bad for such a simple circuit. Of course, with ringing here, it's always say the idea if such a waveform is useful, can be used in a certain electronic schematic. Anyway, I turn now the potentiometer going from the second transistor collector to the base. Let's see. Well, now we are on 8 to 8 kilohertz, and we are now on 1.7 megahertz. Good result, by the way. But of course, this is more or less the ideal situation that I show. And when you do experiments with this schematic, you will surely see that there are all kinds of waveforms popping up. Here, for instance, when I change the 470k potentiometer going from the 100k potentiometer to the base of both the transistors. Here we have this. Let's listen. No, of course we cannot hear this. It's 365 kilohertz anyway. And well, so here we suddenly have a kind of good waveform anyway. Turn the potentiometer again. So well, with these 280 picofarad capacitors in the circuit, thus this one and this one, we are going to higher frequencies. A good other example is, for instance, to switch in here a 180 picofarad capacitor and here a 0.22 0.22 microfarad capacitor, that means, of course, there's an enormous difference, say, in the pulse pause time, etc. Thus also in the frequency. Let's see, listen, look. Perhaps it works. Can get it working. Yes, it works. Though, here you see the waveform. It has a, say, it's a needle pulse here. And you can surely hear out of my loudspeaker, perhaps, very, very high sound. Say we are now going to the kind of ultrasound. That's also possible with such a simple circuit. Anyway, so change the scope a little bit so that it is better visible. What happens when we turn some potentiometers? You can perhaps hear the high frequency. There's also the ventilator sound of my scope. Anyway, it works. Here we have again another sound. Say all these waveforms are usable for certain applications. So let's go to the lower frequency bands, switching in the, well, this is also a waveform suddenly. Well, I have already showed it. Thus, let's see again. 384 kilocycles, anyway, no problem. Switch now the Bose. Well, this is again one capacitor of 0.22 microfarad and another capacitor of 180 picofarad. You could hear on my audio amplifier all these strange effects. This is pure noise. Say it's in the 18 kilohertz band, 14 kilohertz up to 18 kilohertz band. And now back to the more or less audio range. Well, with two capacitors of 0.22 microfarad. Again. Change the values of the potentiometers. I only have 1 minute on my camera anyway. Well, let's stop with this kind of good waveform on 1.2 kilohertz. Thanks for watching. Like I told, it is an oscillator with some possibilities, but on the other hand, very sloppy waveforms. Thanks for watching.